In robotics, I think one of the challenges we have is balancing a super optimistic future, which is compelling and should exist, with building a business. And you're more likely to stumble upon problems where there's a smaller supply of founders who are equipped to solve those problems. When it comes to like foundational models, the model architectures don't actually need to be all that exotic.
Welcome back to the Foundry Alley, where we dig a little bit deeper into important and impactful technology products, why they matter, and the people behind them. I'm your host, Sri Kalimani. I have an education and background in robotics. This is part two of my conversation with Ted Lutkus, the founder of Onyx Robotics. If you haven't watched part one yet, I would recommend starting there. Onyx is building the software and tooling layer for controls engineers, one that takes the tedious and often manual work of fitting controls and dynamics models into real-world hardware so that you can spend more time actually designing your controllers. This is impactful for any company whose product depends on the accuracy that you achieve from taking simulation into reality. Automotive, aerospace, robotics. In this episode, we get into more of the technical details with a product walkthrough. We talk a little bit about simulation to reality problems, as well as the data discipline and kinds of triaging you really need to do to be able to work effectively in this space. So if you're a builder, if you're somebody in the technical aspect of things, you will really enjoy this one. It's clear how much research has really gone into building this product to get to the root of the user problems and then making a product around this. So I'm sure this will be extremely impactful to anybody building in the space, especially in robotics and physical AI. I'm super excited to share this conversation with everybody. Let's get into it. What's the best way somebody can get started if they wanted to try it out?
Yeah, sure. Well, so it kind of depends how someone's coming at this problem. If you're maybe like in the robotics world already and you've been like following all the latest papers and you want to try this stuff out, definitely check out our docs and as well as our open source repos. This is that companion UI. So this is not something that you explicitly have to use if you're using our product. You can do everything through the terminal or through code. One of the aspects of starting to lean into data-driven models for controls and simulation is that it's fantastic because I can get this accuracy out of my systems. But one of the challenges is that now we have this dependency to the data that we are producing models from. One of the benefits of the first principles mathematical model is that I can, the math is the math. You don't necessarily need, Newton didn't need a version control on some of his equations. But we might need version control when it comes to what data was being used and the models we're creating from that data. So this first view that we have here, this is a graph that's sort of just clearly showing to us like where models are coming from, what data they're associated with. If we're modifying data and processing it before training, can capture all that stuff in a way that will already handle a lot of the Slack messages you might get from a teammate if they're trying to like reproduce the same results that you got. Yeah. So we're looking at an example model that was trained on some test data that I have in here. And notably, you'll see at the top this breadcrumb of what we're looking at, but each model sort of gets tagged with a separate UUID, a separate ID of like that particular model and how it was trained. So if we're looking at these models, I might have hundreds or eventually maybe thousands of different models that were tested out and tried. We basically do all of that sort of researching and experimentation for you through our infrastructure. Looking at this model, I can just immediately see what it looks like when it's predicting against some ground truth data. These plots are sort of generated for you. I can look into the model and understand exactly the parameters of it, the inputs and outputs of that model. But notably, I sort of mentioned how there's maybe lots of models that are trained. And so if we come to this tab here, each one of these black dots on the screen represent separate model trainings that were done on that original data that I was leveraging. And so, this kind of ties in, sort of directionally speaking, some of the work, for instance, the like Andre Karpathy had like a auto research as like this repo that kind of attracted some attention. This is one of the directions we've been moving in with this tooling for a while, is kind of the long tail of what this product and tooling will become, is a place where you could just drop in your data after you kind of collected it raw from your hardware, and just kind of set loose this automated, fully end-to-end process of AI researching and experimentation on that data to eventually arrive at models that work particularly well at predicting the dynamics of that data.
This is super cool, and I think I definitely relate to kind of having this like versioning and being able to see things more in like a user-friendly way, essentially. And so, did you guys kind of start out with like a foundation model, or eventually kind of build out your own? Like, how is that?
When it comes to like, working with foundational models and things like that, what we've found though, for the most part, is that the model architectures don't actually need to be all that exotic even to like get some really meaningful results immediately. Look at like this model, for example, the number of parameters here being like 10,000 parameters and the memory footprint being like less than 50 kilobytes. The bar of entry in terms of the models being perhaps lower on the architecture side, because we are purposefully trying to train models that could be used for really fast real-time simulation, or potentially embedding models onto something like a drone with very limited compute. We're sort of operating in this regime of tiny models to begin with. With that said, there's definitely, there's some exciting research that we want to dabble into, with potentially training some larger foundational models, potentially on hardware that Onyx has collected on its own, and then maybe fine tuning these models for different, customer applications. Could be an interesting direction to experiment. But, this is maybe where, what's the saying, like, perfect being the enemy of great or something.
Yeah.
But, we wanted to start with an MVP where we were not going to be making any of the customers we're working with, let's say, participate in our research, and instead deploy things that we knew were ready for prime time sort of today. So that's where we started with, and it's actually been pretty exciting to see just how far we can get when you have the right training practices in place, the right recipes for data. And so that is primarily the vector maybe that we've been pushing along up front.
What has been I guess, your experience with real world testing and kind of, simulation to real world transfer?
On the sim to real side, this is where that element of like combining the first principles model with the learning based model becomes really important, because a lot of the times we're coming into work with someone who, they're essentially chasing that last mile of simulation accuracy. But, by and large, like, one of the things I think we're pushing for and that we've seen is that you should just aim for, like, as best as you can, solving that system identification problem. I think some of the big learnings have just been like, if you can address sim to real problems upstream, it will make a lot of your diagnosing of problems downstream easier. And you can have more faith that you've done your diligence upstream. It's one of these holes that you should fill regardless, basically, if nothing else, to like keep your sanity when you're testing your RL policy, that you're not, fine tuning or reward shaping the wrong things when you just don't have accurate simulation to begin with.
Yeah, awesome. I have so many more questions and I would love to learn. I'd love to end with maybe like a call to action piece. What is something you would say to an engineer? And then also, what is something you might say to an investor and a founder?
On a call action side, I'll start with the engineer because that's easy. Come talk to us. Check out our website. We would love to like talk with folks that are working on this kind of stuff. If you are working through problems when it comes to system ID or dynamics modeling or really anything at this layer of the stack, we love this stuff. So we want to talk with you. We want to like hear more about those problems. We're kind of obsessed with this layer of the stack and building tooling that's going to help all of us. So to engineers, come chat with us. To VCs, so we just finished a little over a month ago, finished raising our pre-seed round, which is exciting. So that's a 1.5 mil round. It's going to let us sort of start building out on top of our early traction. To VCs, come talk to us. I'm more interested in the engineers right now than the VCs. VCs can find us, one way or another, or go talk to, folks who invested in us for now. To the founders, like the robotics founders out there, there's different pieces of this, but I think maybe one of the most important pieces in robotics is try like your hardest to find a stream that is moving with you, that like wants to progress forward. In robotics, I think one of the challenges we have is balancing a super optimistic future, which is compelling and should exist, but balancing that with building a business. And these things can be really challenging to go hand in hand. And it's one of the most exciting times to be a roboticist. But at the same time, I would encourage you to like really sort of be willing to like ask questions of people in terms of pain points and business needs that need to be solved, and to maybe just like take a few notes out of the SaaS, SF ecosystem. A lot of the fundamentals that like YC, publicly shares on their like YouTube videos and whatnot, a lot of the fundamentals still apply, just in a different, you're in a different domain and different context, which is a benefit because you're more likely to stumble upon problems where there's a smaller supply of founders who are equipped to solve those problems, but the fundamentals still apply. And I would say don't trick yourself too much into thinking that because I'm doing something really hard, that gives me an excuse to ignore the market, interest and the sort of business aspects of things.
Awesome. I learned so much today. Ted, thank you so much for sharing, for presenting, and yeah, just taking the time.
Yeah, of course. It was so fun talking with you, and yeah, it's exciting to sort of be operating in a space, and nice to be sharing our stories.
Thank you so much for listening to this episode of The Found Reality. If you enjoyed this one, make sure to interact with it, like, subscribe, comment, as well as sharing it with people that might find it useful. Be sure to check out Onyx Robotics in all of the links provided below. We'll see you in the next one. Thank you.